All right, ladies and gents, let's talk about our favorite topic, inverses. All right, so we said that inverses really just means opposite. And we see, sorry, you guys, that's why I'm not an English teacher. All right, so we see our inverses or opposites in three really big ways. Our first way is going to be with a table, and this is the one that most of us are most comfortable with. So we said that if I have a table, we have x and f of x. We know f of x really just means y. And my x values are going to be, let's say, 2, 4, and 6. And my f of x or my y values are going to be 3, 5, and 7. When I come down here to make my inverse table, what I know to do, we have our f negative 1 of x. We know that negative 1 really just means inverse. That's what tells us what to look for. We really just switch our values. So my x values, my original x values of 2, 4, and 6 are now going to become, my y values of 2, 4, and 6. And my y values of 3, 5, and 7 are now going to become my x values of 3, 5, and 7. So if we were to summarize this, we would say with a table, we switch our x and y values. All right, the second way that we see this is in our graph. So we see it graphically. So let's take a look at our graph. I have my x-axis, I know, is the one that goes side to side horizontally, negative on the left and positive on the right. My y-axis is what goes vertical. It goes up and down with a negative on the bottom and positive on the right. And we said if two functions are inverses of each other, they will always reflect across what we call this identity line, which is what the equation of this line is going to be, y equals x. So this is what, if we want to recall back to last semester where we made those foldables, this is what we got to see. So let's say we know that logarithmic and exponential are inverses of each other. So if I draw my exponential function, it's going to look something like this. We have an asymptote along the x-axis. And with my logarithmic function, we know it looks something like this. So I can see that if I were to if I were to have both of these functions, my exponential and my logarithmic, on the same graph, and I folded that graph on my identity lines diagonal, that eventually, right, not with my artistic skills, but if I did this on my calculator, this red graph and this yellow graph would reflect over my identity line. So when we think about graphically, we know that inverse functions will reflect over the identity line. All right, you guys. So the last thing that we're going to take a look at is our, we need more space, is going to be how we do this when we talk about algebraically. So I'm going to move this up a little bit so that we have more room. All right, you guys, algebraically is the one that tends to give us the most trouble. But we got this. Algebraically. It'll take some hard work, but nothing we can't do. So we have two big steps for when we solve for inverses algebraically, and this is true no matter what function we have. Our first step is going to be to switch x and y. And our second step is going to be to solve for y. And the solving part is genuinely or generally what gets us. Because we know when we solve, we're going to use reverse PEMDAS. Or we can call it SADMAP. So let's take a moment to think about what those opposites are, right? We talked about how inverses are opposites. And so when we're thinking about this algebraically, we are just trying to uncover our y, and we're going to do that with a lot of opposite operations. So let's think about our opposite operations. Our opposite of addition is subtraction. Multiplication, we said, is division. Of squared will be square root. Of cubed will be cubed root. And of exponential, we said, will be log. So let's do an example. If my first example is f of x equals, let's say, the cube root of x plus 2. And we know in all of these, our goal is going to be to find our inverse function. So what I'm going to do is first, I want to change that f of x to a y because I know those are the same thing. I don't want to get confused. Then I know my first step is going to be to switch my x and y. So let's do that. I'm going to have x equals the cube root of y plus 2. So I now know that I should solve for y, right? So I have to look at this in particular and see what is required of me with this equation. The first thing I see is that my group in this case is going to be a cubed root. So I know I can't unlock anything from this cubed root until it is alone on one side of my equal sign. So I see that I have that plus 2. I'm going to get rid of it. So I'm going to undo it with a minus 2. And I'll end up with x minus 2 equals the cube root of y. I now see that my cube root of y, my group, is alone on one side of the equal sign, so I'm ready to undo it. And I recall from my list of opposites that I undo a cubed root with a cubed. So let's do that. I will cube both sides. And on my right side, the cubed and the cube root cancel out, and I am left with y. And on the left side, I have x minus 2 cubed. I see that I have y alone on one side of my equal sign, so I have officially found my inverse function. I can check this by graphing my original function and my inverse function and checking their tables to see if they're opposites, or by graphing them and reflecting on their graph, seeing if they reflect over the identity line. All right, let's do another example. Let's say that f of x is equal to, let's say, negative 2 times 2x minus 3. All right, so we're stepping up a little bit in the world. First thing I notice is that I have that f of x. I don't like that one. So we're going to say y equals negative 2 times 2 to the x minus 3. So now my first step is always going to be to switch for x and y. So let's switch x and y. I have x equals negative 2 times 2y minus 3. Now I recognize that I have an exponential, so I want to get this exponential alone on one side of the equal sign. And I see I got a lot going on. I got a lot going on over there. So I'm going to come back to PEMDAS. PEMDAS, I know that S stands for subtraction. I see that I have subtraction. So I want to undo it by adding 3 to both sides of my equal sign. I'll cancel out on the right side, and I'm left with negative 2 times the quantity of 2 to the power of y